Top 5 habitable planets ranked by number. A detailed exploration. The search for life beyond Earth has captivated humanity for centuries. While we haven't yet discovered definitive signs of extraterrestrial life, the discovery of thousands of exoplanets, or planets outside our solar system, has fueled our hopes and ignited our imaginations. Among these exoplanets, a select few stand out as potential candidates for harboring life as we know it. Here's a detailed look at the top 5 potentially habitable planets, ranked by number, based on current scientific understanding. 1. Gliese 6.7cc. Location. This super-Earth orbits a red dwarf star called Gliese 667c, located just 22 light-years away in the constellation Scorpius. Size and mass. Gliese 6.7cc is at least 4.5 times more massive than Earth, making it a super-Earth. Orbit and habitable zone. It orbits its star in a mere 28 days, placing it squarely within the star's habitable zone, where liquid water could potentially exist on its surface. Challenges and considerations. Red dwarf stars are much cooler and dimmer than our Sun, meaning Gliese 667cc would likely experience tidal locking, always presenting the same face to its star. This could lead to extreme temperature differences between the two hemispheres. Additionally, red dwarfs emit powerful flares of radiation, which could potentially strip away a planet's atmosphere and make it uninhabitable. 2. Kepler-2, 2b. Location. This super-Earth orbits a Sun-like star called Kepler-22, located about 600 light-years away. Size and mass. Kepler-22b is about 2.4 times wider than Earth. Orbit and habitable zone. It orbits its star in 290 days, placing it within the habitable zone. Challenges and considerations. Kepler-22b's size and mass raise questions about its composition. It could be a rocky planet like Earth, but it could also be a gas giant or a water world. Further observations are needed to determine its true nature. 3. Kepler-62f. Location. This rocky exoplanet orbits a red dwarf star called Kepler-62, located about 1,200 light-years away. Size and mass. Kepler-62f is about 1.4 times more massive than Earth. Orbit and habitable zone. It orbits its star in 267 days, placing it within the habitable zone. Challenges and considerations. As with Gliese 667cc, Kepler-62f orbits a red dwarf star, raising concerns about tidal locking and potential radiation hazards. However, its smaller size compared to Gliese 667cc might make it a more promising candidate for habitability. 4. Kepler-186f. Location. This rocky exoplanet orbits a red dwarf star called Kepler-186, located about 500 light-years away. Size and mass. Kepler-186f is about 1.1 times more massive than Earth, making it one of the closest in size to our planet. Orbit and habitable zone. It orbits its star in 130 days, placing it within the habitable zone. Challenges and considerations. Similar to the other planets orbiting red dwarf stars, Kepler-186f faces the potential challenges of tidal locking and radiation hazards. However, its smaller size and closer resemblance to Earth make it a particularly intriguing candidate for habitability. 5. Kepler-129b. Location. This exoplanet orbits a star similar to our Sun, located about 550 light-years away. Size and mass. While its exact size and mass are still uncertain, Kepler-1229b is considered a strong candidate for a rocky planet. Orbit and habitable zone. It orbits its star in 89 days, placing it within the habitable zone. Challenges and considerations. The uncertainties surrounding Kepler-1229b's properties make it difficult to definitively assess its habitability. Further observations are needed to confirm its size, mass, and atmospheric composition. Conclusion. These 5 planets represent the current frontrunners in the search for habitable worlds beyond our solar system. While the possibility of life on these planets remains speculative, their existence highlights the vastness and potential diversity of the universe. As our technology advances, we can expect to discover even more potentially habitable planets, bringing us closer to answering the age-old question, are we alone in the universe?